Hi, my name is Gina, and I am doing my video on the measures of position. The definition of measure of position is a method that can identify the position that a particular data value has within a given data set. It can be determined by using quartiles to measure the location in a data set. Quartiles are values that can divide a data set into 4 equal parts and can be shown symbolically by using Q sub 1, Q sub 2, and Q sub 3. Q sub 1 is the first 25% of the data. It's also known as the 25th percentile. Q sub 2 signifies 50% of the data. It's the 50th percentile. What makes it easier to remember is that it's your median. Q sub 3 signifies the last 75% of the data. It's the 75th percentile. For example, find the 3 quartiles in the data set. I've used the values of 10, 3, 7, 8, 4, 15, 7, 9, 1, 7, 9, 3, 6, 12, and 16. The first thing that you want to do is to put your values in order ranging from the lowest to highest. Next, you want to find your quartile 2 by locating your median. I basically did this by doing process of elimination from both sides, and I got that the quartile 2 was 7. Next, you want to find your quartile 1, which is located on the right, and quartile 3, which is located on the left. Your quartile 1 equals 4, and your quartile 3 is 10. I did this by basically looking at the 7 set of numbers before them or after the mean and finding the middle of those numbers. So now we know that Q1 equals 4, Q2 equals 7, and Q3 equals 10. The interquartile range of a data set is the measure of variation that give the range of the middle 50% of the data. The formula is interquartile range equals quartile 3 minus quartile 1. It's basically the difference between the largest and smallest values. I use the same example that I used for the first one to find the interquartile range. Step 1, once again, is to put them in order from lowest to highest, and then locate your quartiles, which we also did in example 1. Based off the data that we already know, we use the formula interquartile range equals quartile 3 minus quartile 1. We know that quartile 1 is 4, and we know that quartile 3 is 10. So this gives you interquartile range equals 10 minus 4, which gives you a value of 6. A box and whisker plot is a graph used to show the median quartiles and extremes of a data set. A number line is used to show the distribution. And to draw the box and whisker plot, you can use the 5-number summary. The 5-number summary is a method used to summarize the distribution of a data set. It consists of your minimum, your maximum, and your quartiles. Q1, Q2, and Q3. So now we are going to draw a box and whisker plot using the data from the previous examples. Once again, we put our data set in ascending order from lowest to highest. Then you want to find your minimum and maximum values. Putting your values in ascending order is the easiest way to do this. Your minimum is the lowest value of your data, and your maximum is the highest value of your data. Therefore, your minimum is 1, and your maximum is 16. Then you want to locate your quartiles, which we've previously done. Therefore, our 5-number summary consists of the following. Your minimum is 1, your quartile 1 is 4, quartile 2 is 7, and quartile 3 is 10. And your maximum is 16. Next, after you have all your information, you can use that to draw your box and whisker plot. You start with a number line. I went by 2s to draw my number line. After you have your number line, you plot the 5-number summary data. So we have our minimum of 1, our quartile 1 of 4, our quartile 2 of 7, and our quartile 3 of 10, and our maximum of 16. So to draw our box and whisker plot, you want to start with 3 lines horizontally through your quartiles. Next, you want to attach those lines to form a box. You attach your minimum point to your first quartile and your maximum to your third quartile. And from our data, we can see that the box and whisker plot is skewered right. And that's it.